Welcome everybody. Welcome to Java 101 presented by Team Roverdrive or us. We are very glad and happy that you guys are able to make it here. We are excited to teach you guys about STEM and more specifically Java. Hopefully you guys are excited to learn. We are Team Roverdrive, as I already said. We're in our fourth year competing in FTC, and we've been pretty successful. Everybody presenting, all four of us presenting here are actually in our first year on this team, and we're loving it. And that's why we want to spread some information to you guys. So with that, let's get started. So what is Java? You probably have, what is Java? I want to ask you guys first, have any of you ever used Java before or have seen it before?
I made a few programs using Java.
I've
done Java before.
What have you guys done with it? Like, what programs did you guys make?
I made a choose your own adventure game using Flutter, and
सही बात करती है ना मोटो I'm reminding you because you are doing this in the
Okay, that's pretty cool. What Java is a programming language, as you guys probably know that. But what a programming language allows us to do is allows us to communicate with the computers. We can tell the computer what to do. We can tell it to do something. We can tell it to pick something. We can tell it to do pretty much anything. So the problem with this is computers mostly understand everything in binary or ones and zeros, like here, as you see here. But it's too complicated for us to understand. So what us humans did is created a programming language that can be converted into this binary for computers to understand. So how that is converted is through this compiler and JVM, which converts this Java over here, bottom left, right here, into bytecode, which is kind of the middle right between Java and binary, and this bytecode is then translated to binary, and then the computer understands it. So now we don't have to read it 10111 blah blah blah. We can just write it like this, and the computer will understand us. Now, how is it's just a coding language. How is it different? I'm pretty sure you guys have used block coding before, but how do you guys think Java is different than block programming?
I think it's different because you're actually typing like real code instead of it's in block coding. It's sort of like code that's already written and like that you put in a block.
Okay,
right?
so yeah, it is. So when you talk about like actually writing, what are some other things you have to watch out for when you're actually writing this code? Okay.
Spelling errors?
Yes, exactly, spelling errors. That's because Java is actually more similar to English than block coding. Probably kind of obvious, but when you write Java, you have to worry about every single letter is in the right place, all the spelling, all the periods have to be in the right place. Even the right letters have to be capitalized, or else the program won't work. But block program, you don't have to worry about that. All you have to do is kind of just make sure the blocks connect with each other and make sure the program works.
The blocks are very limited use than the typing.
Exactly, which is actually another difference. It's pretty limited because you can't really fit every single command into a block, or pretty much you can't fit everything into a block. So that's why block programming is usually used in the beginning when you're starting to learn code. But as you go more advanced and go through the ranks, I guess, you start using Java for more complicated things. And the most, I guess, important difference is that Java is object-oriented, which, if you guys don't know what it means, it's okay because we're going to be going over it later in this presentation. why is it so important? Like, I'm going to ask you guys, why do you guys think it's so important? Why do you need it?
You can make phone apps that are installed on phones that can be very helpful, like gaming apps.
So you can make gaming apps. Okay. What else?
It can be used to execute hard tasks that humans can't do, like you program like a crane, for example, like if it's automatic.
Yes, exactly. So if you look around you, like you said, a lot of hard tasks right now are done by computers because it's just not possible for us humans to do. So we rely on computers a lot more than before. And because of that, we need the computers to do everything right, and we need computers to be able to do everything. So how does a computer know what to do? And that is Java, by coding. So if without this code, the computer doesn't know what to do. It just sits there. It's literally just plastic and metal. You can't do anything with plastic and metal. And also, Java is also what we use to code the robots in FTC and FRC, which are two of the more advanced robotic competitions. So if you guys want to join those, you should definitely learn Java to succeed in those. Where do we write it? You guys might be asking, like, I know why it's important, I know why it's different, I know what it is, how can I start? You can write it pretty much anywhere. You can write it on a piece of paper next to you, you can write on Google Docs, you can write on Word documents, but problem is that you won't know the outcome. You can just write it, but how will you know if it's right, or if it'll do the right thing, or the computer's going to understand? Well, the way you do that is using an IDE, which runs within the platform and converts it to bytecode and then converts it to binary. And something pretty helpful is automatically debugging, which is pretty helpful because it figures out problems in the code, which is arguably one of the hardest things about coding. For this presentation, we're going to be using REPL.it. If you guys would like, you guys can actually go to that right now or wait until later.
Wait, can I use Eclipse?
Say that again? Sorry.
Can I use Eclipse?
Yeah, sure.
Can I use code editors like VS Code?
Of course you can.
Everyone just go to like this IDE for now.
For now, go to this. But like when you're doing it on your own, you can use anything you want.
Yeah, exactly. Because this is just an online IDE, and it's easier for everyone who doesn't have Eclipse or VS Code.
So now it's time to learn the first programming. I'm not going to be going over how to do it just yet. Ashwin will be going over that later in this presentation. So you guys probably know what this does already. It says hello world. You've probably seen it before with other coding languages. Like, it's the first thing anybody does. As you see at the bottom here, this is the code that you type in. There will be everything in this we will be going over later in this presentation. Don't worry about it if you don't know what they mean. So this is the code. Everything here, this will say hello world over here.
So there are 8 primitive data types, and they can store different types of values such as numbers, characters, words or text, or etc. So the first one is byte, and it can hold mathematical integers between negative 128 and positive 127. Short can hold integers between negative 32,000 and positive 32,000. And it can hold integers between negative 2 billion and positive 2 billion, and then long holds really, really long numbers, as you can see on the slide. So a float can be used to hold decimal values, but it can only hold up to 7 digits of precision after the decimal point. So one example is 50.5. but a double is generally used as a default, and it can hold decimal values up to 16 digits of precision after the decimal point. So one example is negative 234.894. A Boolean stores values, and it will either be true or false, and a char can hold any characters such as A. So strings are used for storing text, and a string variable contains a collection of characters surrounded by double quotes. So for example, we have in the slide, we have string greeting equals hello and parentheses and then semicolon. And then you can also find the length of the string by using the length parentheses method. So we have string text equals all the letters of the alphabet. And so the computer would print out the length of the text string is 26 because that's how many letters are in the alphabet. And then you can also make your text uppercase or lowercase by using txt.to uppercase or txt.to lowercase. So the input is the data that we give to the program, and the output is the data of what we receive from the program as a form as a result. So one example is that this program would say enter an integer, and the input would be that you would put in a number, so let's say 23, and then the output would be that the computer would print you entered 23. So that's one example of input and output functions. Variable stores values like someone's name or age, and we already went over these, but these are the more important ones and ones that you will be using more often. So again, int stores integers, Boolean stores true or false, string stores words or text, and then double stores decimal numbers. And then in your code, you would want to put the data type, the variable name, and then the equal sign value semicolon. So some examples are int age equals 10 semicolon, string name equals Jeff in parentheses semicolon, and then Boolean b equals true semicolon. And then in Java, you can also use arithmetic operators. So just like in math, you can use the plus sign for addition, the subtraction sign, the minus sign for subtraction, the asterisk for multiplication, the slash sign for division, and then the percentage sign, it returns the remainder. So one example could be if you have 2 and then you put the percentage sign 5, it would return 2 because that's the remainder between 12 and 5. So then for the increment operator, you would have 2 plus signs, and that's the same as x equals x plus 1. And then if you have 2 minus signs together, that's the same thing as x equals x minus 1. Next slide, please. So you can also use comparison operators. So if you have 2 equal signs together, that means equal. And then if you have an exclamation mark and equal sign, that means not equal. You can have less than or equal to signs, greater than or equal to. And comparing multiple integers will output in a Boolean, and this can be really useful when you're adding logic to your program. But one thing is you want to be careful is that if you use only one equal sign, that is for assigning a value to a variable. So one example is int age equals 10 semicolon. But if you have 2 equal signs together, that checks if 2 values are equal. So if you have 1 equal 1, it would be true because those 2 numbers are the same. But if you have 1 equal negative 1, that would be false because those 2 numbers don't have the same value. And then for conditionals, they can add logic to your program and can execute certain segments of code if a certain condition is met. So in real life, one example is that if the food is hot, you would put it down and blow on it. If the food is cold, put it in the microwave. But if the food is none of those things, you would eat it. So in code, you could use if-then statements or if-else statements. And so inside the parentheses for the conditions, you must put a Boolean, which would be true or false.
Okay, so now that we've talked about conditional statements, let's learn about loops in Java. So in programming languages, loops are just used to execute a set of instructions or functions repeatedly when a certain condition is true. And there's 3 types of loops in Java. There is for loops, while loops, and do while loops. So first let's talk about for loops. So the Java for loop is just used to iterate a certain part of the program several times. And it's recommended to use a for loop if the number of iterations is fixed and you know how many times you want to repeat this code. So in a for loop, the first thing that you should do within the parentheses is initialization, which is where you define the variable that you will be using. And then you have the termination condition. And what you do here is you just state the condition, which is a Boolean, and it will return true or false in order to determine if you want to go into the loop, and determines how many times you just want to execute the code. And then you have the update statement. So what this does is it just changes the variable's value. Usually it's an incrementation or decrementation, and this makes sure that it's not stuck in an infinite loop. So in the example, you can see that in our initialization, we're setting int I to 1, and then we're checking if I is less than 5. So if it's less than 5, it'll continue into the loop, and if it's not, it'll just break out of the loop. So, and then after it checks this, it'll increase the value of I by 1. So the output of this would be 1, 2, 3, and 4. And it doesn't print 5 because it's I is less than 5, not I is less than equal to 5. So the Java while loop is used to iterate a part of the program several times, just like how a for loop is. So if the number of iterations isn't fixed, then it's recommended to use a while loop. So it works pretty similarly to for loops, but the implementation is slightly different. So what it does is you need a Boolean or condition within the parentheses, and if this condition is true, then the body of the loop will execute. So in the example, you can see that we're setting the int test to 3, and then the while loop just checks if test is less than 20, and then it will go in and print out test, and then it'll increase test by multiplying by 2 each time. So as you can see, the first loop is run because 3 is less than 20, so we'll go within, and each time it'll be multiplied by 2 and continue into the loop. So the output would be 3, 6, and 12. And it wouldn't continue on after that because after this, it would be greater than 20. So the last type of loop is the Java do while loop, which is used to also iterate a certain part of the program several times. However, you use this only if you want to execute the loop at least one time. So no matter whether your variable fits or whether the condition is true or false, it will always execute at least one time. So as you can see in the example, you are just setting the int I to 1, and then instead of checking the condition before executing, it'll directly go into do, and then it'll print out I, so it'll print out 1, and then it'll increase I by 1, and then it will go in and check if the condition is true. So do while loops always execute the loop at least once. So how do we make sure that our loop isn't continuously running, or if we just want to break out of it at least like a little bit earlier than usual? So for these, we use loop controls, and the 2 main loop controls are break and continue. So break is just used to exit the loop, and if you just want to completely break out of the loop, you just use this break operator. And then there's continue, and this also breaks the loop, but instead of completely coming out of the loop, it just continues on to the next iteration. So an example of this would be in break when you, so if, as you can see inside the for loop, you're doing if I is equal to 4, then break out of the loop. So this outputs 1, 2, and 3. It doesn't output 4. This is because when I is equal to 4, you're breaking out of the loop, so it no longer executes any of the statements after this, and it completely just exits the loop. So you're not printing out 4 or any of the numbers that come after it. However, in continue, when I equals 4 and you put continue, then it won't output 4, but it does continue to output all the other numbers after it because you're continuing to the beginning of the iteration rather than completely breaking out of it. So now that we've talked about loops, let's talk about switch case statements. So in a switch case statement, you're passing a certain expression into this statement, and then it checks this expression against each case to see if there's a match. And if there is a match, then the associated block of code within that certain case is executed. So as you can see on the right, the expression that's being passed is grade. So you're checking if the grade that's passed is equal to any of the cases. So in this situation, the grade that's being passed is B. So it'll check each of the statements, and it's not equal to A, but it is equal to B. So it will go within case B, and it will execute your grade is 80 to 89%. So that's what it'll print. However, if the grade you were passing was Z, you can see that there's no matches for that. It's only A through F. So what it'll do is it'll go into the default, which is just, it's an optional keyword, but it's used to check for errors, and you should usually include it. So it will just output enter a valid grade. And as you can see, after each block of code within the case, you are saying break. And this break is just used to exit the case because you don't want to be stuck within that certain block of code forever.
Well, let me get this straight. I have a question. So is it like searching? Is that the thing?
Oh, could you question?
Yeah. So the is it just a code block that tells if the code has like is not working or something wrong with it? Is that's what the block says?
You mean for default?
Yeah.
So in default, basically if they pass a certain grade, so in this situation, if they pass grade for say Z, there's no grade Z, right? It won't match any of the cases, so it would just go directly into default, and it would tell them to print or enter a valid grade because it doesn't match any of the cases.
Oh, yeah, that makes, yeah, thanks.
Okay. So now we're going to learn about object-oriented programming. So Java is an object-oriented language, and what this means is that object-oriented programming is just a way of organizing programs as a collection of objects, each of which represents an instance of a class. So what is a class? A class is just a blueprint or kind of a prototype from which objects are created. And objects are just software bundles of related state and behavior. So classes are kind of like templates from which multiple objects can be created from. So an example would be if you had class fruit, then the objects created from this class could be apple, banana, and mango. And the cool thing about objects is that they all have all the kind of, what do you call it? They have all the, in Java you would call it methods or functions and variables from the class, but they also have their own functions. They have their own defining features. Even though they're all fruits, they're all different in their own way. And this goes the same for the other example. If you have class car, then the objects from this class would be Tesla, Toyota, or Mercedes. And these are all cars, but they do have their own functions. They do have different features to each of them. So let's see an example of this in Java. So inheritance is an important feature of object-oriented programming, and this just allows us to create a new class from an existing class. So if you have class animal and it has the method eat, if you create the class dog that extends animal, so extends is just used to inherit all of the class animal's methods and variables. So class dog now has all the methods and variables from animal, but can also have its own methods. So dog is an animal, but it also has its own features. So for example, if class animal had method eat, dog could have its own methods like method bark or something that's specific to a dog. And that's basically how that's how inheritance works. So why do you think object-oriented programming is important? It could just kind of make the code faster and easier to execute. You wouldn't have to repeat yourself multiple times. Like, you wouldn't have to rewrite methods in each class. You could just use methods from a different class. And it allows you to create reusable applications, which allows you to write less code, and it makes for a shorter development time. So now that we've learned some of the parts of code, how do you start writing your code? So each Java program has to have a class and a main method. So the class definition just consists of the class keyword, and this is followed by the name of the class. And it's a pretty good practice to give the class a name that relates to the code within it, so that you can understand what the class is used for just by its name. And every class must also have a main method. And broken down, you can see that the first word is public. So public just means that the main method is public, which means that we can call the method from other sources outside the class. So you don't have to be within the class in order to use this method. You can also be in another class and just call this method from there. So static means that we don't need to create an object for the static method to run. They can just run themselves. And void means that the method doesn't return any value. And then main is just the name of the method, and it just signifies that this is the entry point from which the JVM or the Java virtual machine will run the program. So, as you know, all of the presenters today are part of an FTC team, and the language that we use to program our robot is Java. So within FTC, there are pre-written libraries for Java, and these are just collections of code that we use in order to control the hardware of the robot. And these are already pre-written by Qualcomm for FIRST, so we can just adapt them and kind of make them our own. So there's a library for every hardware component, such as servos, DC motors, and sensors, which are on the robot. And an example of a program that we can write or a certain method that we can use on the robot is motor.setPower to 1. And what this would do is make a motor start rotating. And there's also many other methods that we can use besides setting power. There's a lot of methods that we can use to make it drive, to make other motors turn. And by giving these instructions to the motors and sensors, you can create a robot that can execute complex tasks, such as the ones that we do in FTC. So now Ashvin's going to show you a demo of how to actually write your first program and do a couple exercises.
Hey guys, so now I'm going to show you guys a demo, so let me just share my screen really quickly. And can everyone see this site?
Yes.
Sounds good. So let's start off with like the Hello World program that I pre-wrote. And we've already been over all of these programs, so as you can see here, this is like a simple program just talking about, remember how we just went over like the different initializing statements? So now, and we also went over that whatever is in between these two brackets is what's running, right? So in this case, it's just a system.out.println hello world, and that'll print in the terminal. So we can just see that when we click run. See, this site takes a little longer than like Eclipse or I use NetBeans, but it still works, right, in the end. So it ran hello world. And I have a question for you guys. Does anyone know what this ln means right here?
I think it means new line.
Okay, exactly. So it means new line. And do you guys know what happens if we take this ln out and we say system dot out dot print ln unicorns, right? Does anyone know where this will print and where this will print? Because I put a new line right here. So what will happen, you think?
I think they'll both print in the same line.
You think they'll both print in the same line, even though that there's a I put ln here?
Yeah.
Okay.
No.
What about anyone else? Does anyone else know?
I think it might print on a new line.
It's my print on a new line. Okay. Anyone else?
Yeah, I don't think it'll work.
You don't think the code will work at all?
Oh no, I think that I think the code will work, but the question that you asked earlier, I think they won't work.
What do you mean they won't work? Do you mean they won't print on the same line? Or what?
Yeah.
Okay.
Yes.
So you think they'll print on a new line?
Yes.
Okay. So we have 2 new lines and 1 same line. Okay, let's try it out. Drum roll. Print on the same line. This is because the ln defines the next statement. So if I write system dot out dot print ln, or even like no ln right here, and I say say something random, iPhone, right? And what do you guys think will happen now? With the knowledge that we just gained, saying that this
So the third line might print on the new line because the ln must define the new line at the end of the statement.
So you think that it'll print like this, and then the iPhone will be on the next.
I think ln makes it after the exclamation mark. It'll do enter. So I think iPhone will be printed on a new line.
Okay.
I think they're all gonna be on the same line again.
Yeah, they're all gonna be on the same line again. Okay, let's try it out. See, it printed on a new line because once again, the one before defines where the cursor is for the next one. So as you can see here, because there's no print ln here, the cursor is just on the same line. So if I just wrote it, it would just keep writing on the same line. But if I did put print ln here, the cursor would be on the next line. So then the next thing it print would be on the new line. And that's how it kind of goes. So, that's a pretty simple concept. And does anyone have any questions with that? Okay, sounds good. Now let's go to while loops. While loops are simpler than for loops. So once again, we have the initializing statements. And another really cool thing that I like about a couple IDEs, I know REPL has it. I'm not sure about Eclipse or VS Code, but if you're writing like hundreds of lines of code, you can like hide some parts of code if you just want to focus on one main one, right? And you can easily just bring them back. So I think that's pretty cool. I think that's very helpful if you're writing lots of code. So this is a while loop, the simple while loop that I created. Once again, we have the initializing statements, and then we say assign the variable I to an integer which is equal to 1 initially. Okay? So we have it's equal to 1 while I is less than 10, right? Run whatever is in this. So everyone knows that 1 is less than 10, right? So run, instead of this, we'll just say run, or print out I. Just print it out. And then add one number to I. because if we do not have this, it will not be a loop, right? It'll just keep running forever because it'll run I, then it'll go back and it'll say, okay, it's still 1, and it'll run again, and it'll go back, it's still 1. So actually, let me show you if we don't have this, what will happen.
Might crash the computer.
It might crash the computer. See? It just keeps running. So it keeps going even then, right? See, look how many I'm scrolling up and nothing, making no effect. I can keep going up and it'll probably take me forever to get up here. So I'm just gonna clear this. Okay.
Yeah, you're gonna crash the computer.
Yeah, I was gonna crash the computer, exactly. But thankfully this is a web IDE, so like it doesn't have that much strain on my computer. Okay, so now we know why we need the I++, right? Because this guy will be confused, right? He's just doing whatever we're telling it to do. We're saying, okay, just keep track if I is less than 10, right? Let's pretend this while loop guy, he's a man, right? He's an actual person, and he suffers from memory loss. So every 5 seconds, he forgets what is happening. So you give him I is equal to 1, and then he prints this out, but then he forgets what I is equal to. So he goes back, he checks wherever I is. So in this case, it would be 2 less than 10, and then he goes again, but then he forgets again, and this time we tricked him. It's 3, and we keep doing that. But when this is 10 or 11, he realizes that, oh, now I can't print this out because it's over, right? So that's kind of how it works. Now let's say that I want to, instead of printing I, right, I feel like that's kind of boring. I want to print out hello world, right? So I just want to print it out, and I can say 50 until every time I is less than 50, print out hello world. Then add 1 to I. So then it'll be 2. When 2 is less than 50, print out hello world. Then add 1. So let's see if it works. See, it did print. It printed out. I don't know if this is 50 times. I can't trust the computer. It might be tricking me. It might only be doing 49 times because it gets lazy, right? I can't trust the computer, especially if this is like 2,000 times, which I'm not going to do because it's going to crash my computer. So let's say that as a solution to this, I can say hello world plus whatever value I is at the moment. And I can add a space here, so it becomes like that, right? So whatever value I is at the moment plus 1 space I, right? So let's see if it runs. Oh wait,
Did you type 1 in?
Oh no, it's not right. Let me just clear this, and then let's try this again. Yeah, see, you can see 1, 2, 3, 4, 5, 6, all the way to 49. So that's 50 times, right? Like, sorry, it's 49 times because 50 is not less than 50, right? So that's if I had to count all of these, that would take way too long. It'd be a waste of my and your time. But with 2 more characters, we're able to save like at least 2 minutes of our life. So that's a big help. And this is like,
That's practice. Like
huh?
how many?
Wait,
We
say
can
that?
use that if we're making like a program, then we can just test it out to see how many times it's actually.
Yeah, exactly. You guys will be able to practice it in like 2 minutes on this. Like, I'll give you an activity and you guys can try to do it. So this is a very cool thing because it shows you that even with like a much more complex problem, it can be solved by just 2 characters. And that you'll be able to see in many times. Like, I'm pretty sure you can ask anyone from our software team and ask them how many times like they've had a big issue, or they thought it was a big issue, and they were able to solve it by adding a semicolon or deleting 2 characters. So now let's go to for loops. Now, this, you're going to see a lot of similarities, right? You see an initializing statement, you see a less than statement, you see a plus plus statement. And it's basically the same thing as a while loop. The only thing is when it takes up less space, and like two, I personally feel like it's much more professional, and when you're sharing code, it's easier to read, right? Because you have these initializing statements, and then you're kind of reading it like a book or an essay or whatever. You're saying for initialize this as I, or initialize I is equal to 1, then when I is less than 10, add 1 to I, right? It's like one line, and then print out I, and then go back again. When I is less than 10, in this case it'd be 2 because we added we added 1, sorry. Add another 1 and print this out. So it would keep running the same thing. And when you see it, yeah, see, like it ran 1, 2, 3, 4, 5, 6, 7, 8, 9 times. Pretty simple. Same thing. I'm not going to go too in depth with this because it's very, very similar to the while loops, and I feel like that'll just bore you guys. Do you guys have any questions about for or while loops? Okay. So now let's move on to finally scanner, and then we'll go on to cases. So what is a scanner? Does anyone know what a scanner is in real life?
It can scan papers and stuff like that.
It's the thing on top of your printer that can scan papers and upload that to your computer, and then you can edit it, you can make any changes to it, right? You can do your homework on it, and then you can reprint it. And that's exactly what this program is doing. So we're importing the scanner class, which is import java.util.scanner, and we've already been over classes and libraries, so this is a very common thing, like importing things. Then you again initialize it, because without this nothing will run. And then you set a scanner, right? You don't how do you say this? Yeah, so you have to like create a scanner object, right? You have to, so remember we were talking about like the printer, you have to actually have a scanner, right? You can't just not have a scanner and scan something. It makes no sense. So you actually have to create or have a scanner. In this case, you're creating a scanner, and it's like there's two errors which we'll look into later. Oh, I know, it's because this needs to be here and this should be here. Okay, so you need to create the scanner, right? Or else it won't run. It's pretty obvious. Then you're printing out. This is simple. This is our first thing, right? I could replace this with hello world and it'll be exactly like our first code. But instead we're saying enter your username. Then we're assigning the variable username to a string, right? It's a string variable. And remember we went over the different types. There's long, there's string, there's integer, there's double, there's boolean, there's a lot of different types. And then we're saying we're reading the user input. You guys see how there's a my object here and a my object here? That's because it's taking this object, it's taking whatever was scanned in this object, and it's assigning it to this variable, username. Then we're printing out your username is plus the variable of username. So now if we try this out,
do we use print instead of print ln? Because if we use print ln, then the user input will just be on the next line.
no, okay, see, I'll actually that's a good question. Let me show you and then I'll explain it. So if we put Ashwin Aurora, which is my name, and we say your username is Ashwin Aurora, we want this to be print because we want it to be when we click return, right? When we click enter, it's already gonna go on a new line, because that's just like, I'm clicking enter right now and it's gonna go on a new line. So we wanted that when we click enter, it realizes that I'm done and I want to go on a new line, because if I run it when I put print ln here, right? That's what you were asking, correct? Who was asking that question? You see how it came on a new line, and this looks very unpleasing, right? Sure, this looks very, very unpleasing. And then when we create it creates this, right? It's not very nice looking. So that's kind of why we put it print only. And this, of course, you'll get like with experience. You kind of realize, oh, this looks much nicer than this. And of course, it's performing the same task, right? Print ln and print, they're performing the same task. They're just to make it look more appealing. So we've been over if and else statements in the slideshow, and I want to try to use an if and else statement. Let's make another variable. Let's make an integer of confirm is equal to my obj dot next int. Why did I make this int in this line? Does anyone know? It's a very simple question, and I think I already answered it, but does anyone know? Oh, wait, that's okay. It's basically because this is int, this is an integer, and then this also has to be int, right? If this was line, you can't assign an integer to like a string. Like that makes no sense, both literally and in this code. So that's why we're making it into this, and then we're saying we're creating an if statement in brackets, the confirmation number is equal to 1, right? Sorry, is equal to 1. If this variable is equal to 1, then system dot out dot print ln you are confirmed. Else, right? System dot out dot print ln sorry, you are not confirmed. Right? So now what is it saying? Oh, and we can also say is print ln is this your username? Okay, so now what are we saying? This we already had before, right? Everyone understands what we were saying in the highlighted part, right? Everyone understands that? Yes. Yeah, okay. Sweet. So this is what we were saying in the we already know what we're doing here. Now what we're doing? We're asking the user, is this your username? Then we're creating a new object, which is an integer, confirming that it's your username. I assign 1 as yes. You can make this 0, you can make this 3. I just made it 1 for easier. And then you can say, if it's 1, if I type 1, right, that is my username, then it'll say you are confirmed. And if it says, sorry, if it's not, then it says, sorry, you're not confirmed. One thing we are missing here, which I'll add right now, is instead of this, I feel like this is too vague, right? if we're making a big questionnaire, it's like this. It's much less professional. If I say, instead of this, I should say is, close that, plus username, your username. Right? Now what are we saying? We're saying is wherever you just put your username. Now let's try.
Do you need to put a plus after username?
Oh, sorry. Yeah, I missed that. Thank you. Exactly. So you guys did see that red sweetie line, and you guys saw like, oh, I had to add a plus. Yeah, I forgot that. Thank you. So now you can see it'll go through the whole questionnaire. So it'll say enter your username, Ashvin Aurora. Is your username Ashvin Aurora? Or there should be a space here, but I'm not gonna rerun it just for the space. And I clicked say 1. You are confirmed. You see how it went very smoothly, and thanks to I don't know who made the correction.
Anna, me.
Yeah, thanks to we were able to debug this together. So now let's go to our final case. Let me just, one second. Which is cases. Our final case, which is cases. So here what we're doing, and this is the exact code that we just went over, right? So this is very simple code, and you're basically assigning each case and you're to a grade. So right now it'll run very simply. We're already assigning it to B, and it'll run that our grade is between an 80 to 89%. Okay, that's good, right? But we just learned about scanners. So how can we bring scanners into this? It's very simple. It's just 2 lines. We add the import java.util.scanner, and then we say instead of string grade is equal to B, we say this is my object dot what do you call it? Next line. Right? 1 second. Right? So we took this part and we took this part. Oh, wait. Yeah, we need this part to actually create the scanner. And then we're using this part as our user input. So now if we go back here and we add our scanner part. Now what is it saying? Importing scanner, right? We did that before. We're creating a scanner. We're assigning the scanner, the variable grade to wherever we wrote in our scanner. Then we're checking each case with this grade. Right? We're saying
It's kind of like a giant if statement.
What?
It's kind of like a giant if statement.
Exactly. It's a giant if statement, but this is the difference between cases and if statements are I personally feel like they're much easier to just read through, right? Because instead of if that check this, right, it's just all under your checking grade and you're printing it, and it's much easier to write too, right? Because it's very repetitive, at least in this case, right? So now if I click run, and it runs, yeah, okay. See now what happened? A debug, right? A debugger. It's telling me that I forgot to put a semicolon after scanner. Great. If this debugger wasn't there, it just wouldn't run, right? Then I'd go through all 29 lines of code trying to figure it out. is on the first line of code. Very, very, very useful tool, especially when you're writing. Right now it's only 29 lines of code. When I'm writing like 290 lines of code, it's a very, very helpful tool. So, because semicolons are very easy to forget if you're new to coding, because you barely, like, how many of you guys have even used semicolons in your English paper or in school? Probably very few of you, and even those people who have, very few times. So it's a very helpful thing. Okay, now I put my grade. I'll say I got an A in computer science. My grade is 90 and 90. It's 90% to 100%, which is true, right? You can only get an A if your grade is 90% to 100%. But now, if I say, my grade is what, Z, right? Enter valid grade. See, it works so seamlessly, and we made this personalized to our own uses. And that's kind of how you should use code when you want to like play around with it. So now it would be great if everyone could go to this this site repl.it, and we'll give you an activity that you can work on.
Wait, once I click rebel.it, it says code, and it's asking me to log in.
I'm pretty sure you can either log in as guest. Wait, let me try. Yeah, and then you can click start coding. You guys were you guys able to sign in as guest, or did you also create an account?
I created an account like 2 years ago with them.
Oh, okay. Yeah, just you can either just use your Google account, or you really don't have to do this activity. Like, it's just for fun if you want to.
Can I just use the clips?
You can just use clips. Don't worry about it. And if you guys have any VS Code or anything that you want, you can use that too. But I don't know. This is weird. Okay, so this is your challenge. You want to go to whichever ID you have, and you want to have a screen like this, right? Then your challenge is to get.
It's doing the loading thing again.
It's doing the. Oh man. Okay.
Yeah, same.
I'll delete these. Alright. So your challenge is to get it show as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not 11, not 12, not only 9. And you must use one of the loops that we taught you. You can't just say print.ln, print.ln, print.ln. You have to use a loop. That's your challenge. I'll give you guys 10 minutes to do it. I think you guys can do it in 10 minutes. And once you guys are done, just like tell me that you're done, and we'll look at it together. Like, I'll also solve it with you guys. Oh, and if you guys need any help, I'll give you a hint.